Hello students, welcome to SOURAV Sir's classes. Today we would be learning about the geometric distribution. It's defined as, say, a random variable x is said to have a geometric distribution if it assumes only non-negative values and its probability mass function is given as px is equal to x is equal to q to the power x into p, where x goes from 0, 1, 2 and so on, and 0 otherwise. This is used in cases suppose we have a series of independent trials or repetitions, and in each trial the probability of success p remains the same. Then the probability that there are q failures preceding the first success is given by q to the power x into p, where q is equal to 1 minus p. The mean of this distribution is given as q by p, whereas the variance is equal to q by p square. Thus, for a geometric distribution, the variance is greater than the mean. This distribution also satisfies the lack of memory property. Suppose an event E can occur at one of the times t is equal to 0, 1, 2 and so on, and the waiting time or the occurrence time, you can call it anything, so the waiting time x has a geometric distribution with parameter p. Thus, probability x is equal to t is equal to q to the power t into p. Suppose we know that the event E has not occurred before k, that is x greater than is equal to k. Let y is equal to x minus k. Thus, y is the amount of additional time needed for E to occur. Then we can show that probability y is equal to t given x greater than is equal to k is equal to probability x is equal to t, that is equal to p into q to the power t, which implies that the additional time to wait has the same distribution as initial time to wait. Since the distribution does not depend upon k, it is in a sense lack of memory. Thank you for watching this video and stay tuned to our channel SOURAV Sir's classes for further videos on statistical concepts.